For starters, we decided to separate the problem in two different programs. First, we would define the possible distributors from the list of customers by selecting the top 20% of buyers in an Excel using the sum of all the demand for all the products. This gave us a total of 160 possible distributors, from which we designed a table of distances with the rest of the customers, and made a location problem that would limit the number of distributors to 25 while making sure every customer was reached and the total distance was minimized. With this data in hand, we proceeded to make a table of distances between the selected distributors and the rest of the customers. We then started our distribution model defining the sets for our plants I, distribution centers J, customers K, and using the alias function our distributors T inside the customers. We then began to transfer our distance tables for all the possible paths created by our sets. In order to make sure that the limitations for handling certain products of the distribution centers were respected, we artificially inflated the options to transfer incompatible products from their plants to each center. We decided to tackle the problem by product. Therefore, we created a table for the total demand of each product. We decided not to divide it into periods, since it wouldn't change the objective of the task. For our parameters, we include the capacity for distribution centers, capacity for all of the distributors, include the parameters for handling cost of each path, depending on their starting point, as stated in the problem. And finally, create a binary variable for the distributor set. Its function would be to identify in the customer set which ones were selected as distributors. For our variables, we had to create one for each product on each possible path, X being paths starting in plants, Y for DCs, Z for distributors, 1, 2, 3 for their respective products. For our equations, we have our objective function, which consists in the sum of all the costs, each cost conformed similarly as shown here. The distance of the path multiplied by the cost per kilometer we defined as 0.15 added to the corresponding handling cost, all multiplied by the total amount. This for all the products and for all the paths. As a note, it is important to mention that the binary variable previously mentioned should be multiplied to the values for the distributor's path in order to make sure that they only count for actual distributors. For the first constraint, we make sure that everything strength from the plants to DCs is smaller than the capacity for that DC. The second one does the same for the capacity of distributors. Constraints 3 and 4 are the equilibrium constraints for the middle points. Whatever enters to the DCs by the plants must be greater than what goes out to the distributors and customers. Constraint 4 does the same but for distributors. Finally, the last constraints make sure that the demand for each customer is satisfied by the sum of all the paths that reach them, noting again the use of the binary parameter previously mentioned.